In order to satisfy the ever-growing demands of the digital world that we live in today, the importance of safe and secure web applications has become greater than ever before. However, ensuring the security of a particular web application can certainly be a very tricky thing. As part of our Scenario Week project, we created both a secure and a vulnerable version of the same web application called Grades Management System, which is a type of system typically used in any academic environment. It allows teachers to grade students on different courses and enables each student to see his or her grades and upload coursework on an individual page. Our system has a database and two login forms, one for the students and one for the teachers. The hacking demonstrations in this video are for ethical purposes only. So let's go through the top 10 easiest ways to hack into the web application, what they entail, and how they can be resolved. Imagine that I'm a user trying to log into the system. As the first page of the site is start.html, I can directly load the page by inputting the URL. However, if the start is missing in the URL, I'm able to see all the site files in the directory tree. If I'm a hacker, that's what I'd like to see. Security misconfiguration can happen at any level of an application, and it is usually due to unnecessary features or outdated software. In our vulnerable website, the default first page is not configured properly. A solution to this type of problem would be adding a configuration file to ensure the uncompleted URL can be linked to the first page. Although the file directory is forbidden from external access now, I can still access the grades page and teacher administration page if I know the exact name of these pages. Once I input the URL in the browser, I get the function to modify a student's grades. The reason is that access control checks are not made in the application, so potential attackers can access privileged functions of the web app without being authorized by simply changing and forcing their target URL. Our solution is to verify function-level access rights before making that functionality visible in the UI. The application will check if the user has already logged in before it provides any functions. Now I have logged in and checked my grades on a university computer. Having a coursework to finish, I close the tab without logging out of the system. However, if another student comes and loads the previous page, my private data would be exposed to a stranger. Broken authentication happens when a user logs into a particular system, performs different activities, and doesn't log out, leaves the page unattended, or closes the browser tab. As a result, any person can access the user's data as they are still authenticated on that browser. The most secure solution to this problem is for the users to always log out when they leave the system. After I finished my coursework, I renamed it with a specific pattern provided by the instructions, and I uploaded it into the system. It looks fine at the current stage, but in the case that someone else wants to copy my work, he can easily find my uploaded file by constructing a special URL with the name pattern. A direct object reference can occur if the programmer does not use any validation mechanism when exposing a reference to an internal implementation object, enabling potential attackers to manipulate these references. Our solution is to limit the access level of the uploads folder, forbidding all the external access but allowing the internal operations. For this example, imagine I were an attacker aiming to hack into the system without a username and password. With knowledge on how SQL queries are made, I prepared a special string to break the normal authorization check process inside the system. As you can see, I can access all the students' grades without a valid username and password. SQL injections are one of the easiest ways to hack any website that sends untrusted data to an interpreter. They're easier to discover when examining the code than via testing. In our original code, the SQL queries are directly composed of the input data. The string injected by a hacker can cut the query and change its meaning. In this case, the string shown on the screen is the same as or true, which makes all the conditions meet, and the hash comments the rest of the query. A possible solution to this issue is using an escape string function to pre-process the input before making the SQL query. As an attacker, I wouldn't be satisfied with just logging into the system. My main goal would be stealing the user's data. As demonstrated on the screen, I've now logged into the teacher's management system. There is a function to search for students' records. If I simply input a string with embedded JavaScript code, a pop-up window will be created and I will automatically receive cookies from the browser. Now I can share this link to others, and since it appears to be a link from a credible site, I can persuade victims to click it. By doing this, I can collect their browser data in my remote server. Cross-site scripting is the most common web security flaw, and it appears when an application sends a user supplied data to the browser without properly validating or escaping that content. Since we're going to display the string we input again, the string will appear in the new HTML code. Therefore, the hacker's string can stop the normal HTML parsing process and execute the JavaScript code. To solve this, we add an HTML special chars function for string translation. The string in the new HTML file will not be the original one. It can still be recognized by the browser. In our app, teachers have the option to modify students' grades. But what if a student tries to change his grade by himself? If the student knows the principle of the editor function in the system, he can generate a URL with parameters about his grade, such as student ID, course ID, and grade. This URL will send a request to update the grade. Then he can create a web page and embed the URL in the source of an image. He can share this page to one of his teachers for advice. If the teacher is using the system and opens the page, the grade will automatically be changed with the source being loaded. This type of security vulnerability is also known as a one-click attack, as it can trick the victim into sending a malicious request in one click. Attackers can create unauthorized commands and transmit them from a user that the site trusts, thus exploiting the trust that it has in the user's browser. To fix this vulnerability, we can change the method for sending the form from GET to POST, which avoids the attacker's embedding URL in the page source. In general, there are several other common vulnerabilities that software developers often overlook when creating a system. Although these are not present on our particular website, they can include using components with known vulnerabilities, allowing unvalidated redirects and forwards, exposing sensitive data, and others. It is imperative that developers are very careful with these and that they ensure they do not allow user parameters in redirecting the destination, that they design special algorithms for password protection, and that they generally make certain that any type of sensitive data is properly encrypted. All in all, each of the vulnerabilities listed so far highlight why security is so important in this new era of technology. We hope that you have enjoyed this video and found it useful as well as informative. Thank you for watching.